Friends, and please say some words and then start.
Thank you, Dr. Giri. Am I audible there?
Yes,
Hello.
sir.
Yes, you are audible.
Yeah, thank you. Is my screen visible there? My presentation. Hello.
Yeah, it seems
Yes, sir.
currently
Yes, sir.
is it visible?
Yes, sir, it is visible.
Yeah. Okay. Good morning, all. Myself, Manoj Kumar, working as scientific officer D at Department of Atomic Energy, AMD mainly. AMD stands for Atomic Mineral Directorate for expressing few for basin, like uranium, red metals, which are used in our program. I will discuss about TMI anomalies. And my main objective of this presentation is to introduce the carbon anomalies and the hypotheses here. Because to understand the TMI anomalies patterns, first you have to visualize how the field behaves in the surface rather than mathematical equations. If you able to visualize the field behavior, then you can understand equations also. One minute.
All of
Yes, today is holiday for time. I will try to complete within half an hour
yeah,
only. Can I
small
start my
request.
presentation?
All of you
Uh,
under note wherever you want to ask the slide number, you can ask that everyone. It's a request.
okay. Okay, I'm starting my presentation. See, before going to TMI anomaly patterns, I will try to introduce some basic concept of geomagnetism. These slides are maybe very familiar to you all, but I will try to give some brief introduction about it. Uh, if you want to look at any position or any point in space, we use coordinate systems, right? There are different coordinate systems. We use X, Y, Z positions to look at any point in the space. If it is in a plane, we use two coordinates X, Y, and we consider it Z plane as a constant. But in space, we use three coordinates, and there are number of coordinate systems. Um, these three are very familiar to us: Cartesian, spherical, and cylindrical coordinate systems. Uh, in Cartesian, actually we use the different coordinate systems because it is in some coordinate systems it is very easy to solve partial differential equations or behavior, field behavior. So we use different coordinate systems. Cartesian coordinate systems we are using in daily life in GPS also, like in UTM, XY, and elevation. In what we do in Cartesian coordinate system, suppose some point is there P, we look at the point on the top of some rectangular cube, length x, width y. We can say these are the distances from point go 0, 0, 0, and these are the distances along x and y and z axes. So in Cartesian coordinate system, we write x, y, z. It is the position of that point. Similarly, in spherical coordinate, we express the top of wait 1 minute. Having some radius, rho is making some angle with z axis, that is pi, and horizontal projection of z axis. We denote theta pi as the position in spherical coordinate system. Coming to this system, as which is having some and height, and this r is making angle theta with respect to x axis. So these are three. If you see all these parameters, there are 9 parameters. And we have Z here in Cartesian coordinate system, which is repeating in cylindrical coordinate system also. And in spherical coordinate system, we have theta, and same thing is repeating in cylindrical coordinate system. So these are actually 9 parameters. If you remove these repeating 2 parameters, there are only uh, 7 different parameters, right? And any three are required at a time to define the position of the point. Okay, what are those 7 points? These rho, r, z, x, y. Out of these 7 points are required to define the position of any point P. What rho is the radius of the sphere coordinate system, which is on xy that is r, and r is having a projection on x-axis that is x and y-axis y. Projection of rho on z-axis is z, and which is making angle pi with respect to z-axis, and projection of rho that is with respect to so now assume that we are taking x-axis as positively downward direction. If you take this x-axis positively downward direction, that is north, and if you connect O and P, it is a vector. If this is a vector, then this vector is called the geometric field. Okay. As I said earlier, to define this vector completely, any 3 parameters are required. Remaining 4 parameters we can easily compute using trigonometric principles. Okay, I think this diagram is very familiar to all. If you combine all 3 earlier coordinate systems in one diagram, you will get this one. Here we are assuming z-axis vertically downward, positive z-axis, and x-axis towards north and y-axis towards east. This F is the geomagnetic field, that is the rho here, scalar component of the geomagnetic field. Here we are rho means only we are measuring the length, not the angle. So it is a scalar component, and which is making a horizontal projection H, that is horizontal component of geomagnetic field, which is having 2 projections on x-axis, that is northing, and y-axis is easting. And the angle between the H and x-axis is d declination, and angle between the horizontal and the field component rho or F is the inclination. Okay. Earlier, actually, in exploitation purpose, people used to measure this vertical component, Z component. But nowadays, people are using proton pulsar magnetometers or alkali vapor magnetometers, which are capable of measuring the scalar component of the geomagnetic field. So that's why we are in exploration. Mainly, we are measuring nowadays is total scalar component, not this vertical one. And for exploitation, this one component is sufficient. That is scalar component of geometry. Within a survey area, generally D and I are not vary that much. So measuring one component is sufficient. So this is what we measure in the field. We measure the scalar component of the geometric field. Okay. Now coming to what we measure in the field. If you go to field and record the data using a magnetometer, you will get some value, some 45,000 nanotesla or something, which contains that mainly 2 parameters. One is geomagnetic origin of internal origin. Another one is external origin. To some cultural noise there or pipeline is there, you will record some noise also that is associated with the cultural noise objects. Generally, in magnetic data, we don't record the data at cultural noise where cultural noise is present, like near the power lines or pipeline or something, iron pipeline or iron fencing. So this component is 0. Suppose if you record, you have to delete it manually. Otherwise, some non-linear filtering techniques are there or frequency domain-based techniques are there. From that also, we can remove the noise. But it is better to remove the entire point if noise is there. Okay, if you remove this noise, internal and external field will record in the data. That is That internal field contains two components. One is background field, that is origin of geomagnetism. Another one is the lateral field, how the crustal will generate. That is due to the lateral. Here K means lateral activity uh, in the near generate the anomalies. So if you record the data in the field, we will get these components. One is outer core origin, another one is crustal origin, then external origin and noise. If you remove the noise, these three components will present. And exploitation purpose, we required only this component, that is field associated with the lateral variation of the susceptibility contrast. So we have to remove background and diurnal. For that, we establish a base station. Base station also record the same components: background, diurnal plus lateral susceptibility variations plus noise. But before establishing base station, first we have to see how the how the base station conditions to establish a base station. First one is it should be accessible. Suppose if you are doing survey area, if you're doing survey in some area, so the base station is accessible to that area. Otherwise, because every day you have to go there and start the base, and after completion of the survey, you have to go there and stop the base. So it should not take much time. Otherwise, you are wasting your time in the base station only. So it should be accessible within the survey area. And next one is this component will not present at the base station because before establishing the base station, we should see how the cultural noise flow. It should be so low because of that we should not establish the base station. That's why before the establishing the base station, the area should be source free. So these two components will not present at the base station. So it will record background field and diurnal. If you subtract these values, actually base station for the ground surface area, background recorded at the field and background recorded at base station is almost same. Because we do surveys in 50 square kilometer, 100 square kilometer area, in which IGRF variations are not much. If it is there also, it will vary in a linear pattern, so we can remove in regional residual separation also. If it is shows some large variations, we have to apply the IGRF correction. Okay, if you remove rover from the base, this background will cancel, diurnal will cancel. We will get magnetic field variation due to the lateral variation of the susceptibility contrast. These these anomalies are called the TMI anomalies. That means total magnetic field. Okay, this is what we measure in the field. Uh, we got TMI anomalies now. Now we have to understand how these TMI anomalies vary with respect to different parameters. So before going to that, we should understand how the secondary magnetic field will generate. Suppose if you put any ferromagnetic material in the external field, some induction, magnetic polarization will take place within that ferromagnetic materials. So dipoles in the ferromagnetic materials will align in that external magnetic field, which causes some magnetization. That is I. Here I is proportional to K, that is I, and H applied cos theta. Here theta is angle between applied magnetic field and the normal to the so if it is 0, sorry, if it is 90, it is minimum, and if it is 0, the polarization is now because of this intensity of magnetization or magnetic polarization, the secondary field will develop. Secondary field is proportional to that I, that is equal to 4-5 times magnetic. Okay, see, if external field is zero, then ferromagnetic random way. Try to align in the our will create another field that is H magnetic field. For our convenience, this external field we say primary field, and the generated field here within the body we call it as secondary magnetic field. Then TMA anomaly patterns are mainly dependent upon the interaction between this primary field and secondary field. How primary field generated how secondary field generated with respect to primary field, and whether it is parallel or anti-parallel to the applied field. So coming to factors affecting TMI anomalies, there are mainly two types of factors. One is body parameters or properties. Yeah, another one is orientation of body with respect to the applied magnetic field or primary field. Don't confuse with primary and secondary with respect with EM fields. Here I am using primary means applied field, secondary means generated due to the alignment of dipoles of ferromagnetic body. Okay, there are some 10 parameters which will affect the TMI anomaly patterns: inclination, declination, dip, and strike. These four parameters are defines how body is present with respect to the applied magnetic field or primary field. External magnetic field strength H and magnetic susceptibility. These two factors are working as a proportionality constant. If these are increases, then TMI anomaly amplitude will increases. And remanence depth D1 and D2, depth to the top and bottom, and body dimensions. These are the body parameters which will also change the TMI anomaly patterns. So we will see one by one how TMI anomaly patterns vary with respect to these parameters. With this, I want to put a hold. If you have any doubts, please ask, because we are moving to another concept. Before this, if you want to ask anything. No, no. Okay then. Okay. First, we will see how TMI anomaly patterns will vary with respect to inclination. See, geomagnetic inclination means it is the angle between the horizontal and the field direction in a vertical plane. So most of the field of internal origin can be represented by a dipole. Dipole is having the northern pole in the southern geographical pole. So in the southern part, if you see here, the field is coming out from the surface. So if you want to represent this in a cross-sectional way, this is the way to represent. Means it is the surface, it is coming out from the surface. I is equal minus 90. And in the intermediate latitude, it is means I is equal minus 45. It is making some angle with the making some angle, that angle minus 45-degree angle with the surface. And if you go further north, now the geomagnetic field vector is going downwards towards the towards the north pole. So here we represent as plus 45, and at the north pole the angle is 90-degree, and the field vector is perpendicularly downwards. If you see here in the north pole and south pole, the anomalies, the field direction is completely different. So field anomaly is also different from the north southern hemisphere and northern hemisphere. Here in the so anomalies also will change. Okay. For our easy understanding, first we will take dike models, because it is very simple to explain the dike model and easy to understand the dike model. So first we should understand this TMA anomaly patterns at inclination I is equal to 0, means at equator. K is positive, means positive susceptibility contrast. Body is having positive susceptibility contrast. Strike is east-west. So here strike is east-west. So we will take the data in the north-south direction, perpendicular to the strike direction. So suppose assume this is our surface. We will draw profile from south to north. This is the conventional way to draw a profile. And suppose this is the cross-sectional view of the dike. Strike is in the east-west direction. So along the north-south direction, we will get the cross-sectional view. At equator, I is equal to 0. The field is completely horizontal. There is no vertical component, only horizontal component will present. Because this horizontal field is cutting our body, which is having some positive susceptibility contrast, then secondary magnetic field induced in this. So south and north poles we induced like this. Because field is going from south to north, the north pole will develop in the geographical north side. Here we have southern pole of the dipole field. That's why this north pole is generating here towards the geographical north. Now, because of this south and north within the body, there will be a secondary magnetic field. This field goes like this from north to south. Here F is the primary field and this green color bars representing the secondary field. If you see here, over the body, we are the secondary field is opposite to the primary field. That's why if you compute this final field, resultant field, we will get low here. This low because of the secondary field is opposite the primary field. So our positively susceptible positive susceptible body at equator having east-west strike, we will get negative anomaly. And here, due to this side lobes, we will get some positive peaks here. These are very minimum. Um, See, this is the same figure. Uh, because of this direction of F, we will get south and north and like this. Here, there, F. So we will get negative anomaly over the positive susceptibility contrast body. Now coming to some intermediate latitude in the northern hemisphere. Why here I am saying northern hemisphere? Because we will get different anomaly in the southern hemisphere, but for same inclination. So here I will discuss about the northern hemisphere first. Then later we will go for southern hemisphere. So in the northern hemisphere, as I said earlier, the magnetic vector goes downward. I is equal to plus 90. Because of this, south and north will induce like this. In the earlier side, these are induced in the horizontal plane. Now it is oblique to the body, and these south and north poles create the secondary magnetic field. This is no more symmetric. It will create some oblique second field lines like this. Here, if you see in this region, it is opposite to the applied field, external field, primary field. Secondary field is opposite, like this. It is going like this, and primary field is like this. So we will get negative. But if you come here in the southern side, the secondary field is in the same direction with the primary field. So we will get the positive peak here. The resultant sum will be some positive peak in the southern side and a large negative peak in the northern side. This is for positive susceptibility body having dip of 90-degree vertical body in the northern hemisphere and east-west body. And if you go to some further north, 45 degrees, then this positive peak will increase and negative peak will decrease because this addition will become more. That's why we will get some positive peak, high positive peak. At 45 degrees, we'll get a sine curve. Means here the positive and negative both will be same amplitude. And if you go further north at 60 degree, the positive peak will dominate. We'll get high positive peaks, and the negative peak will be less. So we will get high amplitude of positive peak compared to the negative peak. If you go completely at the north pole, field direction is vertically downward. So south pole will create here and north pole somewhere in the depth. So the field lines comes like this and it will go inside the south pole. So here the field, the applied field, primary field direction and secondary field direction, both are parallel. So we will get positive peak only. There will be no negative peak. This is how TMI anomaly patterns will generate over a east-west body in the northern hemisphere. So coming to the north-south body, if you take the north-south body in the same northern hemisphere, same basic diet, which is having dip 90 degrees, 90 degrees. Earlier I said this equation now. If I is equal to 0, this is the cross-sectional view. So here F is coming out from the screen. So I is equal to 0 means F is parallel to the body. This is north-south body and the field is also north-south. Here angle is normal to the primary field angle is F will be 0. Over in the which if it is trending in north-south direction in the equatorial region. That's why actually irrespective of the body strike we will do magnetic survey in east-west directions only. Sorry, north-south directions only. Because suppose if you do east-west direction, we don't get anything because there is no secondary field, so we don't get anything. So irrespective of the body strike, if you want to do the survey in the equatorial region, we will do in the north-south trend only. Because if your north-south trend is if you do survey in the north-south traverses, we will get some anomalies which are associated with some east-west features. Okay, this is for I is equal to 0 north-south body. If you go little little forward towards north, uh, I is equal to 90. There will be some flux cutting between the body and primary field. So because of that, south pole will create here on the top of the dike and north pole in the and the field lines coming from north pole like this and it will go around like this and it will go to the south pole. That direction is parallel to the applied field direction or external field direction. So we'll get some positive peak here. At equatorial region we don't get any peak, but if if I is 30 degree, we'll get some positive peak. If you move further north, this positive peak will increase. See, here, if you move further north, the amplitudes will increase. Like we don't get any anomalies in equatorial region, but we will get some positive peak at 30, and it will increase like this, and maximum peak we will get at I is equal to 90, because the primary field is vertically downward, and south pole will be created at north will be created at top of the dike and north pole at the bottom of the dike. So field lines coming from north pole and it will go towards the south pole. So maximum amplitude we'll get here. That is maximum peak we'll get here. Very positive perceptuality body. Okay. If you see anomaly patterns, perceptuality body in the which is having dip of 90 degree. See here I written south to north. Here I written west to east. Means if body is at every I value is same. Here, if you get some here also the amplitude will be 100 on, but the phase means that shape of the curve will changes. Similarly, if you go to if you calculate TMA north south body at equatorial region, we don't get anomalies. The positive peak will increase with inclination. So here amplitudes are different, but if you see the curve, that shape of the curve is almost constant everywhere. So there are two factors. In the east-west body, the phase will changes, and for north-south body, the amplitude will changes. Uh, these are the anomaly patterns for east-west bodies and north-south bodies in the northern hemisphere for positive susceptibility contrast bodies. What if the body is somewhat oblique, like body is trending in northeast southwest direction? So we take traverses from southeast to northwest direction. So how anomaly will be? See, if the body is east-west direction, we will get at 45 inclination. Here inclination is 45. We will get some sine curve like this. If it is an east-west body, if it is north-south body, we will get some positive peak. If it is intermediate, we will get average of these two. So this positive peak will increase. See, we will get high positive peak and some low positive peak. See, if body is like this, east-west, we will get this curve. If body is north-south, we will get this curve. If body is intermediate, we will get anomaly also intermediate between these two. So that is high positive and low negative. If you want to calculate the field behavior, secondary field behavior, and you can visualize it by practicing. Okay. What about southern hemisphere anomaly?
Excuse me, sir.
Yes.
Sir, can you repeat the past slide once more?
Yeah. See, here inclination we fixed 45 degrees. If it is east-west, we will get sine curve like this. Positive and negative are same because inclination is 45. For north-south body, we will get only positive peak. If it is intermediate, then we will get anomaly also intermediate between these two intermediately. Like here positive is there, here positive is there. So we'll get more positive. And this negative, we will here there is no negative, so we'll get less negative. So more positive and less negative we will get. Is it clear?
Sir,
Yes.
can you please
Yes.
explain the field lines of this northwest body?
Uh, uh, field lines. Actually, it is 3D. In 3D now, we unable to draw in 2D. You have to visualize it only. But see, that two components will include here. This is one slide. This one means you have to visualize in cross sectional view also as well as along the strike also. Because of both, uh, we will get the anomaly. I will draw the figure and I will share with you.
Okay, sir.
If because I will draw the figure.
Excuse me, sir.
Is there anything? Yes.
For north-south dipping body in the equator, how the positive lobes are coming, small positive lobes are coming. I couldn't understand that.
North south body.
Yeah,
No,
initial.
that is east west body. Uh, east west body. No? Profile direction is east west.
Yes, sir. This.
Profile direction is east west. Strike is east west.
Yes.
Here, see, maximum opposition is there. But here, in the edges, field anomalies are parallel to F, no? Here, that secondary field, which are coming from northern dipole and northern part of the dipole, and it will going inside the southern part of dipoles. That's why some positive peaks will get. These are very minimum peaks.
Okay, sir.
Excuse me, sir.
Yes.
Sir, in this, what does this green color contour, sir? Are they magnetic field of this anomaly body or like total resultant field of?
No, actually here red color is external magnetic field. That is geomagnetic field.
Okay,
Because of that geomagnetic field, the ferromagnetic body dipoles will orient. Because of those orientation, we will get the secondary is associated with orientation and
sir.
field developed due to this body.
Sir, this means the magnetic field of the induced magnetization is positive.
Yes.
Okay. So here in this example,
See, if you,
any like
once see here, see once here H is applied field, that field, because some intensity of magnetization we will get, that is orientation of dipoles, that is we call it as magnetic polarization. Because of that, there will be a secondary magnetic field that that is 4 5 times of I. That H bar is representing the those green colors are representing that H bar. Okay, is it clear?
okay. Yes, sir.
Here H is applied field, H bar is secondary field. We can say it is primary and it is secondary.
Okay.
Yes.
Can you please explain the case where the body is north-south and the no anomaly is found?
Yeah. If you see this equation, here theta is angle between normal to the body and applied magnetic field. So you can write uh, if you if you want to write something like along this if theta is angle between the body orientation and applied magnetic field orientation, then you can write sine theta. Here we are writing here we are taking as angle between normal and applied field, so it is cos theta. If you take the angle between body itself only, it is sine theta, right? So if you
Yes.
go there, if you go there, if you take the angle here, body is south, north south, field is also north south. So here, if you want to write sine theta, here angle is 0. So kf sine 0 is equal to 0. Otherwise, if you take the angle as normal to the body, then cos theta, then it will be 0.
Okay, sir.
Means there is no flux cutting actually along the body. Only this applied field, sorry, external field is present. So there is no flux cutting. So no secondary magnetic field. That's simple. Both are parallel.
Okay, sir.
Okay. So is there anything else? Um, okay. We discussed up to here, I think. If you come to southern hemisphere, the field is coming outward from the surface like this. For I is equal to minus 30 degree. So secondary field will generate in this pattern. So here the maximum we will get maximum here, so positive here, because the secondary field direction is parallel to the prime applied field, and here negative because this is anti-parallel to the applied field. So in the southern hemisphere we will get positive towards north, but in the northern hemisphere we will get positive towards the south. See in this slide, compared both images. In the northern hemisphere, field behavior is like this. Here, the secondary field is parallel to the primary field, so we will get the positive in the southern part. But in the southern hemisphere, we will get the positive in the north part. Okay, is it clear?
Sir, here not mean geographical north or like magnetic north.
Geographical north only.
Okay, thank you, sir.
Uh, Geographical north only. Uh, Remember this one, because our study area generally falls in the northern hemisphere. No? So if you see some books of Australian books or something, you will get this type of anomalies. Otherwise, mostly they discussed about these anomalies only. Uh, Here in the southern part, we will get the positive for east-west body. We'll get the positive and maximum negative in the northern part. But if you go to the southern hemisphere, the positive part is towards the north. Okay, and if you go towards little bit south, this inclination will become minus 60. Then this positive part will increase and will dominate the negative part. We'll get less negative and more positive.
Please remove the charger.
Okay. Okay. If you go completely at the North Pole, we don't get any negative negative part. Only with this. If you compare both southern hemisphere anomalies and northern hemisphere anomalies at equatorial region, both are same at I is equal to 0. In the southern hemisphere, you will get the positive peak in the northern part, and if you go towards the south, this positive will increase, and over the southern pole, we will get only positive. Similarly, in the northern hemisphere, positive peak will increase in the southern part, and if you go towards north, this positive peak will dominate. Over the north pole, we will get positive peak. Okay. Then similarly for east north-south bodies, we will get positive peak only. In the equatorial region, we don't get any peaks. If you go towards south, this positive peak will increase. At North Pole, we'll get at South Pole, we'll get maximum positive peak. Earlier, if you see in the northern hemisphere, field direction is like this, going towards uh, uh, going below, going towards the north magnetic, geographical north. So field direction is like this. So it will create the South Pole here and North Pole somewhere in the depth. So field lines coming from like this here, and it will go here. So it will get positive peak. But in the southern hemisphere, the field is coming out from the surface. So we will get North Pole here and South Pole at the depth. So field is also secondary field is also like this. It will come from this and it will go like this and it will go here somewhere in the southern pole. So in both cases, we will get positive peak. So for north-south body, we will get only positive peak in the southern hemisphere and northern hemisphere. But east-west body, we will get mirror images. See, this is the mirror image for east-west body. So there is a conventional way to write the southern hemisphere anomalies is just write northern hemisphere anomaly and change north here, south here. Then you will get the southern hemisphere anomaly. Okay. I'm repeating this. Suppose if you want to write the southern hemisphere anomaly at sorry, this is northern hemisphere anomaly. For I is we got some positive and some negative peak. Same anomaly if you want to write the southern hemisphere. That means I is equal to minus 30 degree. For that, either you have to draw this, otherwise just change, keep north here, put north here and south here. So that itself represents this one. Means we are not drawing this one, just we are changing the code south and north. Okay. These are the southern hemisphere anomalies. If you get some east-west body, you will get low at the equator and positive peak towards the north will increases. Over the pole, we will get only positive. And for north-south bodies, we don't get any anomalies, and we will get positive peaks. It will increases and get maximum positive peak at I is equal to 90. If you observe carefully, in the southern pole, irrespective of the body strike, we got high, very high susceptibility body. Bell shape curve we got. Similarly, if you go to the northern hemisphere, this slide, irrespective of the body strike, we got bell shape curve, high curve over the high susceptibility body. So that's why we apply RTP filter. What it does is, if you apply RTP filter, irrespective of the body strike, we will get positive or a positive body. because we are converting anomalies from some intermediate latitude to pole. Either it is a positive south pole or north pole, positive 90 or negative 90. We will get high over a high susceptibility body, irrespective of body strength. So it is easy to interpret the RTP anomalies. So we apply RTP filter. There are some limitations. Uh, I will not discuss those limitations here. Okay. Is it clear inclination effect on magnetic anomalies? I will discuss dip dip effect. I want to discuss.
Questions, please.
Okay. 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 Dip effect. Earlier we discussed dip is 90 degrees, that is vertically downward. Suppose if dip is somewhat like this, if it is dipping towards the north, if body is dipped towards the north, then that positive peak will increase. See, our a vertical body, it is for I is equal to 45 degrees, so this that symmetric for vertical body. Body is dipping towards the north, this blue curve will come because the positive peak will increase. If body is dipping towards the southern part, this negative peak will increase. Why? Because suppose if it is dipping towards northern part, the field is also the induced anomalies also changes because of the flux cutting between the F and the dip effect. So this positive peak will increase because here the secondary field is parallel to the primary field. You have to practice these anomalies, otherwise you don't understand. After this presentation, try to draw the anomalies so you can understand. Mainly, which depends on your visualization only. Okay, this is for east-west body. Suppose if you do it for north-south body, we'll get bell shape for a vertical body. But if it is dipping towards the east, then we will get steep slope in the western part. Sorry, steep slope in the western part and gentle slope towards the dipping part, like gravity anomaly. See, it is in gravity anomaly, we will get gentle slope towards the dipping part. No? Like here also, you will get because of its orientation, we will get some negative peak also for north-south bodies because of the dip effect. Okay, coming to declination effect. Earlier we are talking about that uh, orientation between the body and the field F. So that is suppose let assume that is theta. For north-south bodies, that theta is 0 at I is equal to 0. But east-west bodies, theta is 90 for I is equal to 0. So if some inclination is there, then this field F will change from its position. So there will be some D. So we should calculate yeah, TMA anomalies for effective angle D plus theta. That's it. Suppose like if you are calculating anomaly for 45 degrees and some declination is there, something like 2 degree, then we should calculate the anomalies for 47 degrees like that. Then remnant. See, if remnant is not present, we will get the secondary field lines with respect to this line. If remnant is
Sir,
present,
can you explain?
then we will get the secondary field line. Yeah, yeah. TMA anomaly patterns are strongly depend upon strike. That is, a strike means the angle between the applied field and the body orientation. Suppose let's assume that is the theta, field is F, and body orientation is angle theta. For east-west bodies, it is perpendicular. For north-south body, it is parallel. So we are calculating anomalies like that. If declination will involve, this f value will change. Suppose if some 2-degree inclination is there, na? Sorry, declination. Some 2-degree declination is there. First, for east-west bodies, we should calculate 90 plus 2 means 92 degrees. Anomalies if angle is 92 degrees. Is it clear?
Yes, sir.
Uh,
Excuse me, sir.
uh, yeah, tell.
Sir, if the
Hello?
inclination and the dip becomes equal, then will we get a zero anomaly? Because it will not cut through the body.
No. It will cut to the surface of the body, no? Wait. Uh, that's right. We'll get the positive peak. It will cut which is cross sectional. This is what you are seeing is cross sectional view. Cross sectional views, it is cutting parallel means maximum. If you see 3D view like here it is parallel to the strike, so we don't get anomalies. If it is like this, uh, if it cut like this, na, we'll get maximum anomaly. This or this, like vertically downward, na, we are getting maximum anomaly. So similarly, if dip and inclination will become parallel, we'll get anomaly. It is going vertically downwards along the body. And this positive peak, we will get only this positive peak. We don't get any negative peak. Negative. Because see, if it cuts like this, south pole will generate here, and north pole at somewhere in that will come from there, and it will go up. So only this portion will get anomaly, and there will be here, so we don't get anomaly. Okay.
Okay, sir.
Uh, Field direction is positive, but body is somewhere inclined, right? If declination is positive, then with respect to the field will change. Like if you here it is 40, if declination 2 degree is there, then it will become 47 degree. So we have to calculate anomalies for 47 degree. Suppose declination is some minus some plus 2 degree, then we have to calculate for 43 degree. Minus 2 degree, then we have to calculate for 47 degrees, like that. Negative 2
So,
degree.
sir, area near equator or in the will we get error due to declination effect as we are far from the pole?
Declination is not like that actually. It is minus 2 plus 2 in if you see will vary minus 180 degrees or
Okay, sir.
in between only say broadly plus or minus 2. Most of the survey areas do only. Because of that inclination, slight anomaly will changes. If it is east-west body, the body will somewhat become oblique to the external field. Suppose if east-west body, it should be 90, but if because of declination, the magnetic vector is changed 2 degree or 3 degree towards west or east. So we should calculate anomaly for 92 degree or 88 degree like that. Suppose if remnant is present in the body, this is the total field vector. Suppose in the external field is like this and the remnant is like this. This will be the resultant field. This resultant field will create the secondary magnetic field. So how this secondary magnetic field will interact with the external magnetic field will generate the TMA anomalies. That's it. What if suppose earlier we only discussed about dikes which is having infinite depth extension. What if the dike is having limited depth extension like say 3D bodies or something? If it is infinite depth extension, we don't get north pole effect. See, only south pole is here, so only we get the positive. But if north pole is present at the shallow depth, it will create negative effect. This is south top one. So result yes, because that north TMA and this is figure he discussed field. It pole. So vertical field total because it poles both will be same component and okay if you go back see we discussed about inclination, declination, dip, strike. We can combine declination and strike in uh, 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 in a single picture also like effective strike we can say like strike is some theta and theta 1 and declination is some d, then effective strike we can say theta plus d, so we can calculate the anomalies for theta plus d like that. And magnetic susceptibility and field strength, these are acted as a proportionality constants. Remnants, because of the remnants the orientation of the secondary field will changes. Depth to the top of the body, it is also acted as a proportionality constant because if it is a shallow depth, you will get maximum amplitudes. Deeper depth, you will get low amplitudes. Bottom of the body controls the anomaly pattern because that second pole effect will come on TMI anomaly patterns as we saw on last slide. And body dimensions, as we discussed about dikes, if in dikes we don't get edge effects because it is the strike is infinite. If it is three-dimensional body, we will get edge effects also. So accordingly, amplitudes will decrease. These are actually positively susceptibility bodies. For negative susceptibility bodies, we'll get just reverse pictures like where low at equator, then you will get positive. This positive peak will same here anomaly negative just with nation and will high. Okay, thank you. Is anything?
So, sir, how much should be the value of K so that observable
Normally, anomaly if 1 or minus 3.
okay.
Uh, it's limestone 0.5 other contact, but anomaly SI will create some anomalies like reduced to only, suppose here, if it remnant is very less, the values all will get a resultant field and reduced field in the same direction. Suppose remnant is strong, then the secondary field will generated based on this resultant vector empty.
Yep.
So how the secondary field is interacting with Mi, the induced field means external field. How the secondary field interact with Mi will generate the TMI anomaly.
So any other questions? Anyone else?
It is difficult to maybe difficult to understand. The concept is very simple but difficult to understand because of this
No
online
worries.
seminar.
So
But if you
he will
practice
share
it
the
on paper, you will
PPT.
get understand.
He will share the PPT. So if you guys have any questions, please ask me in class also. Please don't be hesitate. And this will be really useful. And it was fantastic lecture, I can say. So the anomalies, you have very positive poles and the explanation, the kind of explanation he provided is invaluable. I hope all of you grab the essence of these things, anomalies, how these anomalies will, how the anomalies, whatever you are seeing, the anomalies from the equator to the pole, how they generate. All these things, hope you got nicely. And I thank from the Department of Applied Geophysics, IIT ISM Dhanbad, on behalf of department and on behalf of the GPC 520, that is the magnetic methods class, a very warm, thank you, Kumar. And really, and if you have anything about the internship, so he's here now.
Talk to my group head and he'll let you know.
Yeah, maybe Manoj,
The,
procedure, like how what is the internship procedure? 2 3 words.
see, some if you come, you will get field procedure and basic interpretation. If you internship, you will mostly processing and interpretation, modeling and advanced will use. We don't have field season, so you will deal with real-time data. In the winter,
That is
we
what our
will have
students
field
mostly
season,
interested.
so
They don't want to go to the field. So they are working. They are fine with working on computers.
for data acquisition, you can come from this winter internship.
Anyone else? Any doubts, please? Shanavas?
No, sir.
Yeah. Thank you. So hope all of you understand. So with this, I'm proposing,
Sir,
out
I
of
think, sir, there is some
yeah.
So mentioning that applications, so you will get that.
So can we apply for the summer internship also?
Yes, you can apply for the summer internship.
So
So,
when
sir,
it will be probably, Manoj?
from
What? When will?
Summer internship will be probably on what month?
Probably in May. May that is 45 days training. So in May and June we'll get. That is based on your convenience actually.
Okay, okay.
Um, your academic based on your academic timetable you can apply. Magnet or telluric we are not doing because mainly we are interested in shallow cluster studies less than 1 kilometer. Uh, so, but recently we have purchased AMT instruments and we have CSAMT instrument also. But magnetotelluric, we are not. Is there anything else?
sir,
Any other
we
question?
have to apply through the website or have to mail you.
You have to download the form and from website it is available. Otherwise I will share with you and you offline you have to send that form to director MD. I will give you that address. Before
Okay,
that,
sir.
I will inform that whether they are giving this time or not because earlier it was on hold due to the corona and now
Thank you, sir.
okay.
Students, any other questions? If nothing is there, so I would like to thank you again, Mr. Manoj Kumar, for the